everybody and welcome. Here is some examples on completing the square. I think this is a tough subject, so I've included a video at the end, or an extra example at the end, just to kind of review how this stuff works, because it can be a little confusing sometimes. Alright, so let's look right at example A. It says solve the equation 3x squared plus 18x minus 8 equals 22 by completing the square. Okay, so what we're going to try and do is we're going to try and use a rectangular diagram, but it's going to be a square in this case, alright? Because I can't solve this right now. I have two terms that have x's in them, and they aren't going to be very helpful as far as actually solving, because I can't say divide by 18, because I have to divide everything by 18. So the first thing we're going to do is we're going to have just one side be x's. So it means I'm going to add 8 to both sides, and I'm going to rewrite it over here. So I get 3x squared plus 18x, and then I'm going to have that equals 30. Okay, now one thing I've noticed is that, look, this one's a 3, 18, and 30. All these numbers are divisible by 3, and that's going to make this a lot nicer to work with. Alright, so I'm going to divide everything by 3. So divide this by 3, divide this by 3, and divide this by 3. If I divide everything by 3, I haven't changed what my equation looks like. I've just kind of changed, it's just simpler now. It's kind of like changing a fraction from 4 halves to 2 over 1. Okay, x. So that means I'm going to get x squared plus 18 over 3 is 6x, and 30 divided by 3 is 10. Alright, so now what I want to do is I want to complete the square from this side. So that means I have x squared plus 6x. So that means I have an x squared, and I have 6 x's that have to go in these two boxes. Alright, so that means they have to be the same number. So if I take 6 divided by 2, that gives me 3. So that means I need to have 3 x's here, I need to have 3 x's here. Right? So now I've really broken up this part into these 3 components. Right? But now I'm missing something here. Well, what number goes down here? Well, I know it's going to be x plus 3 times x plus... So I've got x plus 3 and x plus 3. So what has to go in this bottom corner to make it a square? Well, 3 times 3 should be 9. So if this side was x squared plus 6x plus 9, then it's a perfect square. So if I add 9 to this side of the equation, I can't just leave it like this, because then it's not going to be the same equation anymore. So if I add 9 to one side, I have to add 9 to the other side. Alright, so then if I do that, now this whole thing is a perfect square, right? I can rewrite that as x plus 3 times x plus 3, or we can write it as x plus 3 squared equals 10 plus 9 is 19. Alright. So now we can solve it. So I'm running out of room, so I'm going to write it over here. So I've got x plus 3 squared equals 19. Now we can just solve using the order of operations. I can't add these, so I have to undo the exponent first. How do I undo a square? It's a square root, and I should get 2 answers. So I've got x plus 3 is going to equal plus or minus the square root of 19. Right? Because I need a positive and a negative, because this is a negative squared, it's going to be a positive. So after that, I'm going to say x plus 3 equals negative square root of 19, and x plus 3 equals the positive square root of 19. And then from here, I want to subtract 3, and from this one, I want to subtract 3 and subtract 3. So I should end up with x equals negative 3 minus the square root of 19, and x equals negative 3 plus the square root of 19. And those are going to be my 2 answers. Alright? And that's what it says, solve the equation. Good. So now let's do example B. Find the vertex form of this equation. Then identify the vertex and any x-intercepts of the parabola. Alright, so the thing that we have to do here this time is very similar to what we did the last time. The only difference is that instead of adding the 9 to both sides, we're going to use something that's slightly different, but it still means the same thing. It's just a different way of looking at it. Okay, so what I'm going to do first is I'm going to have 2x squared plus 12x, and I'm going to write the plus 21 over here. I'm going to give myself some space because I'm going to complete the square, because right now this is not a perfect square. If I have 12 x's, 6x goes here, 6x goes here, and 6 times 6 is 36, and I don't have the 21 that I need. Alright, so here's another problem. This one is a leading coefficient is 2, and we've been working with 1, so I want to say, can I divide both of these by 2? And I can. So we can say, we get y equals, when I divide it, I'm not going to get rid of it this time, because that is going to change my equation. So I'm just going to factor it out, kind of like reverse distributive property, and put it out in front. So I'm going to get 2 times x squared plus 6 divided by 2 is going to, or 12 divided by 2 is going to be 6x. And then I'm going to leave a space, and I'm going to do the plus 21 out here. I didn't divide this one by the 2, so I'm just going to leave it out. And if I want to distribute that 2 back in, I should end up with this original equation, so I haven't done anything wrong. So now what we're going to do is we're going to look at this part in my square. I've got x squared plus 6x, so I know my x squared goes here. I have the 6x, which means half of them have to go here and half of them have to go here, so that's going to be 3x here and 3x here. And then what goes in this space? Well, it should be 9, right? That way I get an x plus 3 and I get an x plus 3. Alright, so if I put 9 in there, I have to put 9 in here. Alright, so if I do that, now let's be careful because I added 9 inside the parentheses, which means how many did I really add? I added 18 because I've got the 2 times the x squared, 2 times the 6x, 2 times the 9. So I've added 18. So if I add 18 to one side, I could subtract it from, or I could add it from the other side, or I could also just subtract 18. If I add 18 and subtract 18, I really haven't changed my equation, right? If I give you $100 and then take $100 away from you, you still have the same amount of money. Alright, so now let's see if we can rewrite this equation. Alright, and the equation should end up being y equals, the 2 stays the same, x squared plus 6x plus 9, this square, the sum of the insides, I can rewrite as length times width, which is going to be x plus 3 squared, and then plus 21 and minus 18 is going to be plus 3. Okay, good. So we want to identify where is the vertex. The vertex is going to be, remember it's x minus h plus k. So the vertex is going to be at minus, or plus, positive 3 is the same as subtracting a negative 3, right? So that means that it's going to be negative 3, comma, 3. There's my vertex. Okay, so there's the vertex. Good. Now what we have to do is we have to find the x-intercepts of the parabola. So let's see if we can find those. What I'm going to do is actually, you know how to find that one out? I'm just going to go and use a graphing calculator. So let's try that right now. We're going to use that right here. And when we go to our graph, it goes right here. So what are the x-intercepts? Well, that means where a parabola crosses the x-axis, and this one does not at all. So that means we're going to have no x-intercepts. So there's the vertex, and we can say there are no x-intercepts. Alright, if you wanted to try and do this one by hand, you'd say, okay, that means when y is 0, we say 0 equals 2 times x plus 3 squared plus 3. So then to solve this one, I would subtract 3 first, equals 2x plus 3 squared, and then divide by 2, and I would get negative 3 over 2 equals x plus 3 squared. Take the square root of both sides, I get plus or minus the square root of 3 over 2, negative 3 over 2, equals x plus 3. I don't need the parentheses anymore. But now when I plug this part in my calculator, I'm even going to stop here. Because if I plug this in my calculator, what's the square root of a negative number? That means I have to take a negative, some number, times itself, and equal a negative. Well, I know a negative times a negative equals a positive, and a positive times a positive equals a positive. So there's no way I can take a number, multiply by itself to equal a negative number. So this is another way of saying we'd have no x-intercepts. Alright, so there you go. Those are your two examples. Now we're going to have some bonus material just so that way you can review how to do some of these. Okay, so in case you were stuck, let's go through this problem. Find the solutions to x squared plus 8x minus 5 equals 0. So I've got x squared plus 8x, and then I've got this minus 5 equals 0. Since I have two terms that have x's in them, that makes it really hard, right? So I'm going to try and make this into some sort of square. So I have this x squared, and I have 8 x's that have to go in this box. If I want this to be a square, which reduces how many terms that have x's in them from 2 terms just to 1, I have to have these be the same. So I take 8, divide it by 2, and I get 4. So that means this one should be a 4x, and this one should be a 4x. There we go. Alright, so now with these two, I have most of a square, but I don't have this bottom one, right? So I'm going to take x plus 4, and I've got x plus 4. All right. So what I'm going to do here is we're going to rearrange this just a little bit. We've got x squared plus 8x. I'm going to leave a blank, and then I'm going to add 5 to both sides just to get that 5 out of the way. So it means it's going to be equals 5. So we need to add something here to make this a nice, perfect square. So what do we have to add in this bottom corner? 4 times 4 gives me 16. So I should add 16 here. But if I add 16 to one side, I have not kept the equation equal. It's no longer equal anymore because I've added 16 to one side. So to keep it the same, I don't want to write an equals there. That wasn't right. Let's get rid of those. There we go. I should add 16 to this side as well. Okay, so now that I've done that, this left side can be x plus 4 squared, right? Just writing length times width. And then 5 times 16 should be 21. And then we should be able to solve that by taking the square root. And when I do that, I should have plus or minus. So I've got x plus 4 equals the positive and the negative square root of 21. And then I'm going to subtract 4 from both sides. So I'm going to write this as x equals negative 4 plus the square root of 21. 21, there we go. And x equals negative 4 minus the square root of 21. They don't like my 2's. Alright, so that's how we do this type of problem. So completing the square is hard. If you don't really get it right away, that's alright. Keep trying and you'll make progress. Alright, good luck.